Hey there, science fans! Welcome to another thrilling episode where we explore the wonders of physics. Bill Nye here, and today we're diving into the exciting world of kinetic energy. It's all about the energy of motion, and trust me, it's everywhere around us. Ever seen a roller coaster zoom down a hill? That rush you feel is kinetic energy at work, converting potential energy into motion. Or a baseball soar after a powerful swing? The bat transfers energy to the ball, sending it flying with kinetic energy. That, my friends, is kinetic energy in action. It's the reason why things move and why we can do so many amazing things. Kinetic energy is the energy of motion. Whenever something is moving, it has kinetic energy. Anything that moves has it. From the smallest particles to the largest objects, kinetic energy is a fundamental part of our universe. The faster something goes, the more kinetic energy it has. Speed plays a crucial role in determining the amount of kinetic energy. The heavier something is, the more kinetic energy it has too. Mass and velocity together define the kinetic energy of an object. So buckle up, because we're about to explore the awesome power of kinetic energy with some fun experiments. We'll see how different factors affect kinetic energy. Get ready to get your science on. We're going to have a blast learning about the incredible energy that makes our world move. Let's head to the lab and see kinetic energy in action. Kinetic energy is the energy an object possesses due to its motion. The faster an object moves, the more kinetic energy it has. But that's not the only factor. First up, we've got our trusty ramps and a set of different-sized balls. These ramps will help us visualize how kinetic energy works in a controlled environment. If we roll a ball down a ramp, what happens? The ball starts to move, and as it moves, it gains speed. You got it! It speeds up, gaining kinetic energy as it goes. The faster it rolls, the more kinetic energy it accumulates. Now, let's try different sized balls. The size and mass of the ball will also affect its kinetic energy. What do you think will happen if we roll a heavy bowling ball and a light tennis ball down the ramp? Will they behave the same way? That's right. The heavier bowling ball will have more kinetic energy, even if they roll at the same speed. This is because kinetic energy depends on both mass and velocity. It's all about mass and velocity, my friends. The formula for kinetic energy is Ke equals 1/2 mv squared, where m stands for mass and v stands for velocity. So the greater the mass or the higher the speed, the more kinetic energy an object will have. Now let's take our experiment to the next level with our trusty smartboard. This amazing tool allows us to visualize and analyze data in real time, making our experiments not only more accurate but also more engaging. We can use it to measure the speed of our rolling balls with precision. By tracking the time it takes for the balls to travel a certain distance, we can calculate their speed accurately. Once we have the speed, we can move on to calculate their kinetic energy. This is where the fun really begins, as we dive into the world of physics and see the principles in action. Remember, the formula for kinetic energy is Ke equals 1/2 times mass times velocity squared. This formula helps us understand how energy is transferred and transformed. Don't let the equations scare you. It's just a fancy way of saying that mass and velocity are key. The more mass an object has, or the faster it moves, the more kinetic energy it will have. We can even use the smartboard to graph our results, allowing us to visualize the relationship between different variables. This makes it easier to spot patterns and draw conclusions, and see how changing the height of the ramp affects the speed and kinetic energy of the balls. By adjusting the ramp, we can explore how potential energy converts to kinetic energy. Science is so cool. Kinetic energy isn't just for fun experiments, it's all around us. Wind turbines use the kinetic energy of wind to generate electricity. Hydroelectric dams use the kinetic energy of water flowing downhill to do the same. So next time you see something in motion, remember the amazing power of kinetic energy. It's what keeps our world moving and grooving. Keep on exploring, science rules.